Right, so we're going to look at 1.4.2 data structures, and we're going to start with arrays, records, lists, and tuples. I'm not going to talk too much about these because I cover quite a lot in the GCSE. And so if you want to learn more about how to use arrays and code them and stuff, I'll suggest you watch the GCSE videos on that section. So what is the difference between an array, a tuple, and a record? Well, to be honest, records are kind of on their own. But anyway, let's look at arrays versus tuples. So an array is just a set size data structure of one type. So here I've got an array of 4 integers. I can't have integer string or whatever. So the array has to be of one data type here. Okay. However, I can change the values after I create them. So here they're 1, 2, 3, 4, but I could, for example, in code, write numbers, square bracket 2 equals 6, and then it would be 1, 2, 6, 4, because obviously this is a 0, 1, 2, and 3 index. Okay, so that's what mutable means. It means it's changeable. Okay, it's homogeneous. That means they have to be the same data type. It's a fixed size, so it's can't be changed once it's created, and it is index based 0, 1, 2, 3. Okay, you can also have 2D arrays, 3D arrays, but again, if you want to know more about that, you can watch the GCSE video or many videos on arrays. So how is an array different to a tuple? Well, a tuple can basically have different data types in it. That's essentially the main thing. It can have different data types. Okay. Now it's immutable, which means it can't be changed. Now in some languages they will implement where you can change them, but on the course we just say you can't change them. Okay. There you go. So basically it's very similar to an array, except you can have different data types. And it can't be changed once it's created. Sorry. So there are two things. It can't be changed once it's created, and it can have different data types. Boom. A record you can think of more as like a spreadsheet, really, with like fields, like in a database, basically. And so they can have different data types. It's very changeable, but it's not indexed like a tuple and an array are. So you can't do like record 0. It would be done by like some sort of primary keyed field or something. But yeah, they can be changed, of course, and the size is flexible, and they can have different data types because obviously you can set a record up like you would in a database in many different ways, very similar. So that's the main thing. So I don't want to talk about them too much because they're quite easy, and you should know basically the difference between them now. So linked list. Okay, here's actually where it gets a bit more interesting. So a linked list is an abstract data type. Okay, so what that means is it's an idea, right? A list is an abstract data type. Where repeated data is allowed. And a linked list is basically dynamic. What that means is that the items are not stored in the order they appear in the data, not stored in memory in the order. With an array, you've got a chunk of memory, sort of like 100 bytes. Let's say you're storing an array of byte, which is a data type. You could do char, which would be similar, 8 bits. Then I know the 98th number is 98 times 1 byte down the index. Okay, so arrays are quite good at very quick indexing, but what makes arrays quite bad is if you want to insert an item, because let me just quickly go to here actually, and if I showed you sort of like an array, actually I could just borrow this linked list bit here. So with an array, memory address, yep, like that. There we go, brilliant. The data would be stored like this, sort of this would be the first element, the fourth, second, third, fourth, and that's it. Now, if we want to put something in here, we've got to move all those down in memory and then pop something in. And that can be quite slow. And so one of the limitations of an array is that. However, the benefit is if we want to get to, say, the 5th element, we know the size of each element and we can just immediately skip down that far in memory and we're at the right place. So that is the benefit of arrays, but they are not so good at when data has to be inserted. So a linked list solves that. What is a linked list? Well, this is a linked list. Okay, actually I'll go back to you. So essentially, it allows much faster inserting of data. The flaw of a linked list, though, is if you want to get to, say, the 10th item, you've got to go through all the other items to get there because it goes from point to point to point to point. So I'll demonstrate here. So you normally on a linked list have, well, it depends on the implementation, but in the book they do next free, but you don't really need that in real world. But anyway, you have a head, and that tells you where the start of the linked list is. So here, the first item in our list is 17. Okay. Then it tells you where the next item is, and that's at F8. So we go to F8, the next item is 22. Then it says to go to F7, and we've got 78. Then it says to go to F5, and we've got 14. And then that points to null, which means we're at the end of our list. So you can see here that I had to go through the list to find out the data. The difference is though, let's say we want to delete this piece of data. All we do is we take the item that points to it and we'd see where that one points. So this is pointing to F7, F7 is pointing to F5. So we simply pop F5 in there and that's it. And that's actually all you need to do, because 22 will now go to 14. This is deleted. If you wanted, for some sort of security reason, you could null that out if you wanted to actually carefully delete the data. But it could be possible that you don't care about that, and you could even leave it in memory. It doesn't matter. But probably best to clear it, and then you relieve the memory. But yeah, you could delete it, and there you go. And it's the same with inserting. Now, let's say we want to insert the number 5 here. Split between 17. So we want it to go, it's like that, and I want to put 5 in there. So so the next free space, I go there, and I go, right, I'm going to put 5 in there. Okay, now it goes after 17. So we find, what you would do is you would loop through until you find the item that you want to put it after. So you would follow from the head all the way through to the item you want to find. So we found 17, it points to F8. We remember that, make a copy of that down here. Okay. Then we change that to point to our new address. Then we go to, so this one now, so that now points to that. And of course we need to put that in there like that. And now we have exactly that. We go to the, and of course now you would change the next 3 to whatever is there like that. And that's basically it. I do have a slight implementation of a linked list here, where I've created a class called node, which is going to have our data and our next. This little question mark, by the way, is a C# thing. If I don't have that there, I can't have the null value allowed. If you want to have a nullable data, and we want to have null, like you see, I literally initialize it to null, I have to have a question mark. If I don't have that, it will say, you can't be null. Highlight and say, did you want to make it nullable? And then I do. So that's what that means. Nothing crazy. It's just like a precautionary thing. And basically, yeah. So look, this is me inserting some data. This works by the way. I can run it, so I should run it. I suppose at least see it. There we go. 180.29, 23.99 null. And that's me printing it because I've added these things. I've inserted them. It goes at the front, at the end. Sorry. 180.23.99. Nothing crazy there. So this is a linked list. So I've got a link to the head node. And when I create the linked list, I set the head to null. Inserting, I create a new version of the class that I created before, a new node. If it's the first element, there's 2 options here. Is it the first element, or have we got to find the end, basically? So if the head is null, which means currently the list is empty, then we just set the head to our new node and we finish, basically. Otherwise, we basically set this temporary node to the head node, loop through until the next one is null. So loop until we find that the one we're pointing at, basically loop till we'll get to the end of the list, right? And then we set the next one equal to the new node that we've just made up here. And that's it really. And obviously we set the current.next equal to the new node. So we set the current equal to current.next, okay? Because we're looping till we find the end. That's what's going to loop till we find the end. So we keep going on and on and on and on and on. Once the next one is null, found the end, then we just set this node to point to the new one. And the new one, by the way, the default will be null, as you can see here. So my next is always null when I make a new one. Right? Reversing a list is a little bit tricky. I mean, it's not very tricky. It's just about memorizing different variables, basically at the previous one, the current one, the next one. Okay, so we start at the front of the list. Okay, we set the previous to null and the next to null. Okay, and while we're basically what a lot of people think happens with the reverse is that you go to the end and work back to the start, but you don't. As you go to the end, you're swapping them back around. So Yeah, so while the current one is not equal to null, so this basically means go through all of them until we find the end, essentially, right? We set the next one, this is the temporary variable, we take a copy of the current next one. Then we set the next one now to the previous one. And then we set the previous one to the current one and the current one to the next one. It is a bit tricky. Maybe it might be best done if I've shown you on a sort of spreadsheet thing in a second here. So let's look. Let's try and reverse this list. So currently we've got this. Okay, I'm going to take previous, current, next. Okay, in fact, if I line it up next to the code, I can actually run the sort of code by hand, and yeah, that should be fine. There we go. Okay, so let's zoom out a little. So we start off null. Okay, and then the current is the head node, which is $F2, but I'm so lazy I'm going to copy it. And then the next one is null. So is that null? No, right? So next equals current.next. So we go to the current, which is F2.next. So next is equal to that. Current.next equals previous. Now the previous is null, because remember, if you reverse the list, the first item is now going to point to null because the list is going the other way, right? So now the first item here, which did point to, so the first item here, which did point to F0, which we've kept a copy of, is now going to point to null. Right, now previous equals current. So we're going to take a copy of our current and put it to previous, because in a minute we're going to move, right? And then current equals next. Okay, so now we've done that. We've swapped, so we've made this is now the end one, and it points to null, right? And then we basically repeat this process again, because current is not null, so we go on and so forth. So next equals current.next, next equals F0.next, so we take a copy of that, so we go to F8, okay, which is correct. Then current.next equals previous, current.next, next equals current.next, current.next, that's a current one, dot next is equal to previous, so that's now $F2, there we go. Previous equals current, and current equals next, and we go on and go on and go on. And now you can see that by the time when we get to the end, and then as soon as current is null, we just set the heads to the previous one, because it means we've gone past the end. So then we set previous one. There we go. And that's basically how you reverse a list. So what are lists good at? Well, they're very quick. They're very easy to insert, because obviously, yeah, they're just very quick in general. Yeah, so that's a list. There you go. Right, let's go on to the next data structure, which is a queue. So a queue is a FIFO. I don't know, I've not done that better. Actually, I'll write that in proper FIFO, which is first in, first out. So it means that objects come into this. What it can be implemented either using a linked list or statically using an array. So a linked list implementation of a queue allows you to have sort of essentially unlimited things added to the queue. Obviously, you're limited by memory. Whereas an array statics would have a limited size, like 10, and that would be it, and then you run out of space. In the example I've got in C#, which I asked ChatGPT to write, so well done ChatGPT. It did it. I asked it to do it using an array, so it's got a static one, so you can see how big it is. So there are two main types: a linear one, which is probably going to be implemented using a linked list. So a linear one, which is just where the list is from front to back, that's it. Or there's a circular one where the end meets up with the start. And this is probably more likely to be used with the static array. Okay. Why would you use a queue? Well, a printer queue is a good example of a normal queue, where basically print jobs are added to the queue, and then once they're executed, they're taken from the front of the queue and then executed. There is a different type of queue called a priority queue, which is basically where items are removed from the front, but they're not ordered by the time they're added. They're ordered by some sort of priority. So I couldn't think of any great examples, so I thought of this. For example, it could be that you're doing a banking app and you order your transactions based on the amount of money because you want to do the big money transactions first. So if a new job got put in, it would go up the list in priority. Okay, so I'll go through that in a minute with an example on Excel. So anyway, let's go to Q. So obviously here, you add data. Let's say we add 45, 7, 8, 9. They would literally go in that. Okay, and then you do what's called pop, which you remove an element or you DQ an element. Sorry, and then which will remove an element, and they'll come from the front. So if I DQ, so if I add 4. If I did this, actually, this is sort of thing they might do in the exam, actually, like this, and then add, these are all adds, by the way, the ones that aren't there. So you would end up with that. Because you've added 45, added 7, added 8, added 9, DQ'd 45, DQ'd 7. Of course, assuming these get moved down, which they, DQ'd 45, DQ'd 7, and then we added 99 at the end, and there we go. And that's how a queue would work, all right? A circular queue, all right, works with a front, rear, and size idea. So let's say you want to add, I'm just going to really chop the size down. I just realised it's going to take ages to explain. Let's say we've got, so they have a fixed size, right? So the maximum size this can be is 4, right? So, and actually I did get circular queue. There we go. Capacity equals size. Yeah, so this one has a capacity variable as well. So I should have had that on there. But I'll go through that in a minute, the implementation of it and etc. etc. So let's have got a capacity of 4, right? Obviously, what a whopping capacity this one has. So if we add these in, obviously they'll just go 9, 8, 7, 6. And of course the size will be that. And the rear will get put to 3 because it will go like, as you add an element, the rear will move down in the list. But see, now the difference of this is, now what happens is, if I DQ, right? So now I DQ, that's gone. But this stays where it is, okay? So now the front is at 1 and the size is 3, like this. Okay, now if I add 27, pardon me, it's going to add 27 there, okay, and rear is going to get 1 added to it. But the thing is, rear would now be 4. Okay, so you might think, oh, that's rubbish. So what happens is, it actually does equals rear mod capacity. Oh, picked that wrong. Where's it gone? C6. Mod equals mod. Here we go. It's mod on this of that, comma that, but it'll be -1 because of the position, because it starts at 0. So now we get 0. So if I, for example, put that shouldn't be -1. I'll go to 4, and then it becomes 0. You see, and as I go 5, 6, 7, 8, 9, you see. So the rear is the mod of whatever the number is capacity, but of course you would set rear to it. So it would essentially, rear is going to go 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and it's going to do that by just adding 1 and then modding itself. Okay, basically it. So it adds 1, it gets the mod of that and that, which would be 0, so it goes back to 0. And then it would go 0, 1, 2, which if we look at the implementation, you'll see here. Okay, rear equals rear plus 1 mod capacity. So it's just going to go 0, 1, 2, 3, 0, 1, 2, 3, and that's how you get the items in. And that's basically a circular queue. Yeah, that's what it's there for. So obviously you set the circular queue. I'll have a look at the code here. So obviously as we create, I actually don't even create one yet. I didn't even do it. But as you create a, you set a size. Let's do 4. And then of course I could add that, and we would see it go around, and it's got its full. If the count is equal to the capacity, then obviously there's too many things in there. They called it count here. I called it size here. But yeah. So that's it, really. Nothing too crazy. Obviously, you just remove from the front, and when you want to DQ one, you'd remove one from the front and move the front down, up one. And of course, you would do the same with front plus one mod capacity in case your front goes over the edge. So as you add one, your rear gets added. As you delete one, your front gets added with modding capacity. Yeah. Obviously, you check things are empty before you try and remove them and things like that. It's nothing too crazy. Obviously, you can look at this code. It's going to be on the screen. You can pause it, have a little look at different bits of it. But I mean, if you just ask ChatGPT to write a C# queue, it'll circular queue, it'll write this for you. The benefits of AI. Right, there you go.